Hi, this video is going to look at inequalities and regions. So what we're going to do is we're going to look at an area of a graph that fits with certain inequalities. Let's just have a quick look at what we mean by inequalities. Well, if we had something that involved an equal sign, such as that, we know exactly what that's telling us. It's telling us that y is equal to 4. But if we look at inequalities, we're not finding the value of y. We are just being told some information about it. And in this case, so if we do that, it's telling us that y is greater than minus 4. So y could be any number of values, but what it can't be is minus 4 or anything less than minus 4. So it's greater than, and that's what an equality is. Now, if we have a look at the next one, we can see that the sign is pointing in the opposite direction. So instead of saying y is greater than minus 4, here we're saying x is less than 2. So the direction of our sign indicates whether it's greater than or less than. And the way that I think is easiest to see it is that if we look at that sign, it's definitely bigger this end than this end. It goes into a point. So whatever is this side of it is greater. If we look at it the other way round, then we can see that the point is going outwards, so this side would be less than. Okay. If you need more help on that, there will be other videos. The focus here is on showing regions using inequalities. I'm just going to wipe that board and then we'll go back and see what we do here. So we've got y is greater than minus 4. So if we look for the point here, that's where y would equal minus 4. And it figures then that if we go upwards from that line, you can see that the y values are going up. So anywhere above that, y is greater than minus 4. And that's not just true of the axis, that's true of any position above this whole line. Let's draw it in and see if we can make sense. Now, what we're going to do is we're going to use dotted lines, because what that tells us is that y is not equal to minus 4, it is greater than minus 4. And we'll make more sense of that a bit later on. So if I put a line across there, then that is the line where, let's write it in, y is equal to minus 4. And anywhere above that line, we will satisfy that inequality that y is greater than minus 4. And if you're not sure about that, just write in a few points, pick some coordinates and look at them, and you'll see that y will always be greater than minus 4. Okay, good. So that's the first one done. Now let's look at the second one, and it says there x is less than 2. So we're going to do the same thing. We're going to go to find where x is equal to 2, which is here. And indeed, anywhere along that line, x is equal to 2. So we can draw that line in like so. And let's write, that's where x equals 2. So if we're looking for the region where x is less than 2, that is going to be anywhere over this side. If we look this side of that line, x is going to be 3, 4, 5 or 6. So we're looking at this side. Okay, good. So that's our first two lines. Now the third is slightly more complicated. We've got y is less than 2x plus 1. So this is slightly more complicated for us to draw, but it's perfectly doable. And if you've done linear graphs, you'll be used to y equals 2x plus 1, for instance. So let's do that. And in order for us to find that line, we just need to have two values of x and two values of y, because if we get 2 points, we can join those up and that will give us our line. So let's go for something like x is minus 2 and x is plus 2. Let's do that and work out what y would be. So if x was minus 2, then 2x is going to be minus 4. Add the 1 and we would get minus 3. Okay. And then if x was 2, we would have 2 times 2 is 4 plus 1 is 5. And there we have two coordinates to plot. So when x is minus 2, y is minus 3. And when x is 2, y is 5. So there's our 2 points. And once we've got those 2 points in, then we can draw our line. I might have to do that again. That's it. I'm going to start that one again. It's going to look like that, and then we're going to extend down, and there we have our line that represents where y equals 2x plus 1. And what we see is we have got this triangle in the middle. So we've closed off the outside, and what we're left with is this region here, and I'm going to put an R to show it, where all of those three inequalities are true. So if we look this side of this line, that's where y is less than 2x plus 1. If we look at this side here, this is where x is less than 2. And if we look above this line, that's where y is greater than minus 4. So we have now drawn in those lines to show the region that satisfies all three of those inequalities. Okay, I've got one more example, but if you feel confident, you can have a go yourself. So if you want to have a go, pause the video and try it for yourself. If not, stick with me and we'll do it together. Okay, so in this one it says slightly different again. We've got x is greater than or equal to 2. So slightly different. In our previous one, we were told that y was greater than minus 4. Here we've been told that x is greater than or equal to. Or equal to. So x could be 2, or it could be greater than 2. So when we're drawing this line, because it includes x being equal to 2, then we use a solid line rather than a dotted line to show that that line is included within our region. Okay, so let's find where x is equal to 2, which is there. So let's draw a line down that, like so. And we can say that anywhere on this line or over to this side of the line, the right of the line, it fits that inequality. And I'm just going to write in here x equals 2. Okay, that's the first one done. Let's look at the next one. So the next one says y is greater than or equal to 1. So again, it's including 1. So y could be equal to 1. So we're going to use a solid line. Here's where y equals 1. Let's draw that line across like so. And right in there, y equals 1. So we're now narrowing down the region that applies to both to this area here. But we've got a third one to include. So let's look at that. We've got x plus y is less than or equal to 6. And again, we've got to find this line where x plus y equals 6. And it is included, so we're going to again draw it in a thick solid line rather than dotted. And here we're going to pick 2 coordinates. So we could say, well, let's think if x is 1, y would have to be 5 because together they must make 6. So then we could say it the other way around, couldn't we? So therefore, if x is 5, y would have to be 1. So there's our 2 coordinates. When x is 1, y is 5. And when x is 5, y is 1. So once we've got our 2 points, we can take our line, draw it in. We'll label that up x plus y. Sorry, I'm saying one thing and writing the other. Let's write it as I say it. X plus y equals 6. So anywhere beneath that line is going to fit this inequality. And you can see once again we've enclosed this region, so we can put an R in there, and within that triangle all 3 of those inequalities are met. And if you're not feeling terribly confident about this, you can always try a couple of points and see. So let's, for instance, if we looked at that coordinate there, just beneath that R, we've got x equals 3 and y equals 2. So let's see if it satisfies all 3. X is greater than or equal to 2. Yes, x is 3. Y is greater than or equal to 1. Yes. And finally, x plus y is less than or equal to 6. Well, yes, because x plus y would equal 5. Okay, and that is inequalities showing regions. And that's the end of this video.